The focus of this lesson is on graphing logarithmic functions that have transformations. And so the first thing I would do is I would just rewrite my equation so that I could see the transformation. So I like to have my logarithm first, and I also like to have my x term first in terms of what I'm taking the log of. So I'm just going to change those orders around, which does not change my function, just allows me to see the transformations better. And then just remember, whenever you have a coefficient on x, I usually factor that out so that I can see all my transformations, and so I have to factor out a -1, and that's going to leave me x minus 3. And so I have log base 2 of -1 times x minus 3, all minus 2. And so that is important because, one, we can now see the transformations, and we'll be able to apply those transformations to all three of our key points in our function. And the first thing to notice is that this is base 2. So your key points are going to be in terms of base 2. So you have your x, and you have your y, and your parent function is log base 2 of x. So that's how you start off to determine your three key points. Remember, you pick for a logarithm, you pick the y's to be -1, 0, and 1. And then your x's will be whatever your base is, which in this case is 2, raised to those powers. So 2 to the -1, 2 to the 0, and 2 to the first. So just a half, 1, and 2, which should make sense because 2 to the -1 will always be the reciprocal of the base, 2 to the 1 will always be the base, and 2 to the 0 will always be 1. So those are my three key points that would start off transforming, and then also this would have a vertical asymptote at x equals 0 because it is a logarithm. And then initially, just to kind of give you the visual, so you'd have that vertical asymptote, and then you would have your graph. So that's off of these initial first three key points. But then I need to transform each of these points, so each of these 3 points. And the transformations that are present is we have a reflection across the y-axis because we have this negative on the x. We have a shift of right 3 units because we're subtracting 3 from our x. And then we have a subtraction of 2 from our entire function, which is our log function. So that's down 2 units. So I need to apply all 3 of those transformations. So the first to apply is the reflection across the y-axis, which is negating my x. So if I negate my x, all that's going to do is make my x-coordinate opposite of what it was. So I'll have the points -1 half, -1, -1, 0, and -2, 1. And when you reflect across the y-axis, that doesn't change your vertical asymptote. It's still x equals 0, but just note that your graph is going to kind of change shapes a little bit. And then when you go right 3 units, you need to add 3 to your x values. And again, you can draw this on a graph because I know some people are more visual, but in light of just the cleanliness and for the video, I'm just going to kind of show it point by point. But feel free to do this on a graph so you can get the feel of why these points are what the points are. So you're just moving right 3 units from the points that you just had. And so that's just basically adding 3 to all my x values. Now when you do that, your vertical asymptote will also move right 3 units, and so you would see that your vertical asymptote would be at x equals 3. And again, your shape isn't going to change in that case. And then last, you need to move down 2 units, but when you move down 2 units, that's just subtracting 2 from your y values, whatever they were. So -1 will become -3, 0 will become -2 when you subtract 2, and then 1 will become -1 when you subtract 2. And again, moving the vertical asymptote down 2 units doesn't really change the vertical asymptote because that's not moving it left or right. So in that case, your vertical asymptote will still remain x equals 3. And so then now we just need to graph our 3 key points that we got through using transformations. So we have 2.5 comma, negative 3. We have 2, negative 2. We have 1, negative 1. And then we know there's a vertical asymptote at x equals 3. We know the direction of our general shape because we paid attention to every transformation of the way. And so that is our graph, and I'm going to just kind of fill in our key points into our table just so they're there. And then this vertical asymptote is at x is 3. Note that the domain in this case goes from negative infinity to 3, but not hitting 3, so non-inclusive. So that's the domain, which makes sense because of that reflection that it would start at negative infinity and go to a vertical asymptote. And then the range will always be, for a logarithmic function, all real numbers. So this completes graphing by transformations.